Alright, so again for this one we've got, we want to put it in terms of r cos x minus alpha, so we can start there with expanding that out. So again, once you know these really well, you don't need to do the expansion, but it's really handy to do it. I mean, I kind of do it each time anyway. If you know how to do it from the beginning in an exam, if you get ruffled, you should be okay. So hopefully we remember the expansion. In this case, it has a positive here. And what are we comparing it to? We're comparing it to a negative 4 cos x and a positive 3 sin x. Alright, so from that I can see that r cos alpha has to be negative 4 in this case, and r sin alpha part has to be 3. So again, just be careful with quadrants. I'm looking for where sine is positive but where cos is negative from these equations, which is in here. So I've got my part, this is in degrees, so I've got my 180 minus my acute angle here. So what's my acute angle? So sine and cos, so equation 1 and equation 2, we are looking at 3/4. Alright, so it's not a particularly nice angle, but that's okay. Yes, alright, so let's leave it there. Of course I didn't bring my calculator with me, so I will trust this. So our alpha in this case is going to be 180 degrees minus whatever the inverse tan of 3/4 is. So I'd put that in my calculator and store it and use that. Looking at our r squared, we're going to have 3 squared plus 4 squared, so that's a nice one. So r is going to be 5. So we're looking at using 5 cos x minus alpha, alpha being 180 minus inverse tan of 3/4. And we're now, what are we doing? Solving. It does say in that one, give alpha to the nearest degree. So hopefully I haven't made an error. And it looks like, what is alpha supposed to be? Approximately, I think it's supposed to be approximately 143 degrees. Is that right? Something like that. So let's say that. I'll just put approximately here, 143 degrees. Hopefully you've got your calculator and you can check that for me. Alright, so now we can use it. It's really the part 2 we're interested in here. So in this case it's a sketch. Alright, so if we want to sketch it, just remember it's, so you've got your normal cos curve. I'll try and do this one better than I've done the other ones. Alright, so say I did my cos curve between, actually let's go further. Alright, so cos curve, usually 0, let me go to a skinnier pen, 360, 180, yeah, 90, 270, so we've got negative. Okay, I'm just going to rub that out for a second and make a bit more room. Hopefully you're okay with all that bit. Alright, and of course I've written that right in the way. Okay, so to say I did start with this as my y and x axis. I'm forgetting about the grid because I'm so hopeless at looking at those grid points. Alright, So we're saying that's 360, this is 180, this is 90, this is 270, that would be 0, that would be minus 90, this would be minus 180, minus 270, minus 360, for example. All right, and we know straight away the amplitude's nice and easy. We know it's going between 5 and minus 5. So that stays the same, but we've got a shift to the right of approximately 143 degrees. So we're shifting everything to the right where, if I could go back to 143 degrees, which would be, so backwards, so minus 143, let's say it's about here. This will be our new, so you can do your little working out graph and then do it neater next to it. So that's where we're really starting the curve. This will be my new 0 degrees. So I'm really just adding to each spot. So if this was negative 143 degrees, I'm adding 143 degrees to it. So this point here, which was originally 0, it will become 143 degrees approximately. So if this says to graph between negative 180 and 180, I'm kind of, so you could come back. So I'm almost at 180 when I'm here. So 180 will be about here somewhere. So that's 180 degrees. And if we go back to negative 180, we're looking at, so 360, somewhere here would be our negative 180 degrees. So we just want to move everything along to the right by 143 degrees. So you could just add 143 degrees to everything to get approximately where you want. That's using our alpha there. I hope that's helpful. Sorry, that was a bit all over the place.